At Disney Experiences, we have a worldwide team of Disney Imagineers whose sole focus is bringing our stories and characters to life in new and ever-changing ways. I'm in Zurich, Switzerland right now to see our team's progress on some new advancements in robotics. You won't believe what we're doing next. In this episode, we're introducing you to a special group in Imagineering, Disney Research. They represent the very beginning of our development process when sparks of imagination begin turning into reality. You'll learn how Imagineers in research and development blend creativity with technology to envision the Disney experiences of tomorrow. You'll also hear how we're collaborating with the world's leading tech companies to push our storytelling in all sorts of innovative new directions. And of course, we'll have a few surprises for you along the way.
We call it Imagineering.
Kyle, it's great to be here at the research lab in Switzerland. I've seen so many incredible things. Why are we here? Why in Zurich?
Disney's a leader when it comes to entertainment robots. We've got this rich legacy, starting with Lucky, the Dinosaur, all the way to Spider-Man and Stuntronics, our BDX Droids.
Switzerland has become a hub for robotics and AI. At the center of this all is the Swiss Federal Institute of Technology, or ETH Zurich. We partner with ETH, including a shared PhD program. They cover all disciplines from hardware to smart software.
This team here is a leader in creating the next generation of robots.
We have one unified goal, building artist-centric technology to tell new stories with characters like these ones that we see here and bring them really to life so that they emote and interact with our guests.
And it's incredible how far this has all come. It's pretty amazing what's happened in a short amount of time.
We got a big surprise for you, Josh.
Okay.
Hi, everyone. I'm Olaf.
Hey, Olaf.
And you are...
I'm Josh, Olaf. So good to see you. You look amazing.
Olaf is one of our most popular characters.
Absolutely.
He shows up in parades, in live entertainment shows, as well as in character meet and greets. So the demand to bring him to our parks is off the charts. We're excited to announce Olaf will be available in both of our Frozen worlds in Hong Kong and Paris early next year.
I can't even imagine this. Like seeing people meet Olaf for the first time in his form. I think this is going to be just incredible. A really, really inspiring day.
Hands down, this is the best day of my life.
Hi, Natasha. Welcome to World of Frozen.
Hi, Michelle. I am so excited to be here.
I'm super excited too. It's so wonderful to see World of Frozen come to life and coming to life in a whole new way. We will have, for the first time in forever, a self-walking Olaf.
It's incredible. We're going to have next generation robotics characters, and this is the latest cutting edge technology.
Olaf!
Oh my gosh, you're here.
We were just talking about you.
So excited to see you. I can't believe you're here in the world of Frozen.
There are so many people that are super excited to see you here. Walt Disney Imagineering Research and Development did such a beautiful job on creating this Olaf, a self-walking character. And it's really a symbiosis between the latest in technology and storytelling. And I can't wait for our guests to see Olaf in real life.
I know our guests and our fans are just going to absolutely love this.
We're here in Glendale, California, at the headquarters for Walt Disney Imagineering in the R&D facility.
Yes.
We have this huge legacy of building and bringing our characters to life through the latest in technology.
I like to think of R&D as the wizard shop inside the wizard shop. Not only do we have the incredible innovation which happens across the broader Imagineering group, but we actually have dedicated experts
They're really creative technologists here within R&D, fusing together both art and science to bring experiences to life. We've been able to bring that group of people together under one roof to solve some of our biggest challenges.
When you really go back in time, Walt created WED Enterprises to build Disneyland. He didn't have an R&D group. It was a smaller, more nimble thing, but there were specific projects that an extra amount of invention. And so he did have to collect people, and I think of Audio-Animatronics as one of those big ones, but also the illusions and things like in the Haunted Mansion. These were really pushing the edge of technology. When you think about what R&D is today, it really is an extenuation of the original Imagineers who Walt tasked with innovative ride systems, with audio-animatronic figures, things that could allow the guests to step into incredible worlds in ways that couldn't be done if you just had to have actors and other things like this. And when I joined in 1993, R&D was a top secret facility. Actually, we didn't want anybody to know that we had this innovation going on because it was really the technology behind the magic. Over time, though, we've loosened that up and actually do shows like this where we expose it because it's become more and more important for the company to be seen as the innovative and technology-driven company that it is.
The diversity of the work that we get to put some of these talented people against, it's kind of fun doing the impossible, and that's what the challenge is every day. Everyone has their own unique approach trying to get that done, and that's what's great about the job is that it's different almost every single day.
We've got some robots, some droids in front of us. We started from very basic structures with a huge ambition, ultimately, to get that state you're talking about, and now here they are. Talk to us about the progression.
Yeah, we actually started with this humanoid test character. Can we get 2 legs to do stylized walking? We have characters that express emotion through motion. So stylization is important, artistic interfaces are important, and we embrace reinforcement learning as a technology very early on. Reinforcement learning is the way we learn actually as humans. That's an algorithm that brings this capability to a computer. And so we train them to imitate artist-provided motion. They learn to balance at the same time.
Do they actually learn?
They do learn and imitate basically how we humans learn. And over time, really polished motions.
One of the things I think is really interesting is the use of machine learning and AI in order to develop the robotics.
Reinforcement learning is a branch of artificial intelligence, which allows us to take animated figures, bring them into simulation, and then teach them how to walk as if they were a young baby. We can do 10,000 hours worth of training in days. It used to take us years to develop robots. Now, using reinforcement learning, we're able to bring those robots to life in mere months.
Espen, do you remember how I challenged you to create actually a first walking character with 3D printed parts and off-the-shelf actuators?
So you said, can we build a walking robot? And I said, well, I think it'll work, but I don't know. And you said, well, let's do it anyway. If we can use 3D printing, we can build something really fast. Can we make that work? Key idea was, can we, instead of trying to build a perfect, idealized system, let's build an imperfect system and instead try and understand it really well in software. We first took a single actuator and we put it on a test stand and we tried to understand how this thing behaved and moved. Now, when we put it together, we tried it and the RL walking worked first time.
Yeah.
Never happens.
Never happens.
It's a solid foundation that we've then been able to really build on. So this guy doesn't look anything like a BDX droid, but if you really look under the hood and look at what makes this work, it's all building on the same technology, and so this is really what enabled us to then go and build the BDX droids.
We know how humans walk, and so the goal was then, how can we bring this human motion to our robots to make them feel lifelike, and we want to have those robots also perform other motions. So our goal was not to have the robot learn only a single motion from an animator, but be able to perform any motion that an animator asks the robot to do. From the human motion, we first have to retarget them to the morphology that we have here. This character is a bit smaller and you get a lot of imperfection, but then in reinforcement learning, it still is able to learn from this imperfect data, and it extracts basically the knowledge of how does a motion evolve over time and how can I track such a motion. And so it's the same concept again. RL, reinforcement learning, learns in simulation to imitate those motions many, many times. Over time, the robots become better in doing exactly those motions that we ask them to do.
Getting something to work in simulation is one thing. Getting it to work on robot hardware is a different challenge. The physical world, the real world is unforgiving. The robot will break if it falls too many times. Because we took the time to understand how the actuators move, to tune the models, that means that you can really start pushing those motions to the limit.
And then we got it to moonwalk. One motion that is very challenging is something like a moonwalk. You slip over the floor, basically, and move backwards while pretending to move forward. We used human examples of a moonwalk and trained then a policy that can actually do the same on the robot.
You create artistically a target motion and you can stream that to the robot and it dynamically balances afterwards. That's amazing for taking the next steps.
We did great progress in this direction, but there's much more that we can explore and dream of.
First of all, thank you for having me at NVIDIA.
Welcome to the second happiest place on earth.
It feels that way. I think our collaboration is essential.
We're in love with working with Disney. The work that we work on together covers computer graphics, artificial intelligence, robotics, and the fusion of all of that. Disney has been at the forefront of some of the most cool technology invented. But at the core, the reason why we love the work is just because the way you push the technology is incredible. A lot of great technology started in entertainment.
Yeah. The best technology in the world has always been core to enabling Disney to bring the characters to life and immersing our guests in the incredible experiences.
You know, at the core, Disney is a technology company. The joy is so incredible that we forgot about the technology, and that's exactly the point.
We had an expression, the technology behind the magic, because at the end of the day, we want people to believe Olaf's alive. It's not very cool for us to brag about our tech. There's certain characters, or the BDX Droids, you can't put a human in a costume. They have to be in this mechanical form, and yet they can still be imbued with life. My dream, and it will be a reality, is that it's a seamless experience for our guests. If they love us and they experience us on the gaming world, they can bring that with them to the physical world.
That's right.
They'll experience it when they see the films and streaming, and then what they do in our parks can also be referred back to.
A lot of the work that you do inspires whole generations of engineers. You know, what Imagineering is about to put out. In fact, that's always the thing we look for.
There is a tremendous amount of talent out there focused on very specific problems, like NVIDIA, where they are building some of the most revolutionary computer chips that are going into our robots. And what that then allows us to focus on is that emotion, that connection that we are making with our guests. We're taking motor encoder data from the BDX joints and then playing it back so that they can get an authentic droid-like sound. We couldn't focus on that if we were having to build our own silicon and building our own chips in order to bring those robots to life. So NVIDIA has been a great partner to help us do that work on the physical products, but also in simulation.
We're really excited to upgrade the Millennium Falcon with an all-new mission to bring to life the characters, the Mandalorian and Grogu. There are a couple technical dimensions that really help our guests get lost in the story. Every single cockpit is driven by graphics cards, all working in parallel. All of that media is being rendered in real time, giving us flexibility for future upgrades. We've access to the most amazing engineering teams, as well as graphics drivers, to make sure that we're delivering high-quality media to truly transport our guests to that galaxy far, far away. In addition to an all-new story, we also went back and looked at each of the individual roles, pilots, the gunners, and the engineers, and looked for opportunities to further enhance the gameplay. Millennium Falcon Smugglers Run is powered by Unreal Engine. Every single one of our cockpits has 5 projectors that are all sort of tiled together. And so we've had to work very closely with the engineering teams at Epic Games to make sure that the effects that you would get on a single screen at home can work across multiple monitors. The Mandalorian leverages a lot of 3D models. They actually play them back in real time on set. We were able to take those Unreal models directly from production and bring them into our version of Unreal for the attraction. So instead of having to create all of those assets from scratch, we were essentially able to go shopping from this library of existing assets, which allows us to not only bring the story to life much faster than ever before, but also guarantee that it's 100% authentic because it's exactly the same asset that you'd see on screen. It's all about allowing our guests to step into that story world.
Smugglers Run, a brand new experience, the latest in hardware processing from NVIDIA, and our partnership with Epic Games.
It will actually be better quality. Real time. So that the interactivity and agency of the guests can actually be greatly improved, but include scenes, characters, places that will come out with this new movie.
And we're delivering it in Florida and Anaheim at the same time.
When you work so hard on technology and so many of the applications are either invisible or mundane, being part of something that creates these incredible relationships and emotions around the world is also fun for those companies as well.
We're here at Walt Disney Imagineering in our top secret lab, and this is H.E.R.B.I. Even though H.E.R.B.I is technically a robot, he's a member of the Fantastic Four family. We want that emotion and that personality to come across in everything he does.
For H.E.R.B.I, we were able to bring him from an idea to a reality in just a short 3 months.
And that required Imagineering, but also our live entertainment group, artists, engineers, designers, scientists, character performers, all working together to bring this character to life. But in the film, the prop they used on set didn't actively balance. So we had to create a robot that could be in front of our guests that came to life like a character while actively balancing. Inside H.E.R.B.I are a variety of sensors that measure his angle, position, and speed. And 250 times per second, it's checking those sensors and constantly micro-adjusting that ball to keep him upright.
And continue balancing even when we play back fun animations.
Moving his arms that much and outstretching them really changes the center of the mass of the character. Being able to constantly adjust and still keep alive and play those animations really is a pretty cool technical feat. What I love about H.E.R.B.I is he's got so many little details and Easter eggs, whether it's those Read Tech decal labels or the part numbers that are references to the cinematic universe, even his really expressive tape reel face. Every detail of this was lovingly crafted with the filmmakers to make H.E.R.B.I brought to life. Our guests just loved talking to H.E.R.B.I, interacting with H.E.R.B.I, and we are so excited that we were able to bring him to life at Disneyland Park in Tomorrowland. Nice job, H.E.R.B.I.
More and more, we want to be able to deliver these characters in their actual form that you see them in films and on TV or streaming faster into the parks.
With our most recent robot, H.E.R.B.I, which we brought day and date with the Fantastic Four movie rollout, we went from concept to design and in the park in months.
Yes. I remember we were at Pinewood Studios, and when we met with Matt, the director, he actually told us he redesigned H.E.R.B.I to not just be hovering constantly, but to be on a ball balancing so it could go to Disneyland. The minute we heard that, we of course had to say,
do it.
We got to do it.
All that wish fulfillment that any of our guests see on the screen now can be a physical experience with our guests.
And the actual animators who animate the films can actually help animate these figures, which was not the case in the past.
Is there a favorite project that you've seen in R&D that really gets you excited about the potential and what we've done in the past?
I have to say, I am a fan of BDX Droids because I think that's just a great story of how what was created here as a prototype has ended up in the movie. When Jon Favreau saw them, he's like, I have to put them into the Mandalorian Grogu movie.
So we got 2 legs walking the first time we tried this on hardware. And then this inspired us to do a true character, a Star Wars droid that can really express emotions. And if you look at their legs, they actually resemble one another. There is some similarity there.
Well, I can remember this walking through research and development in Glendale. I saw one of these. It was a prototype at the time, and I couldn't believe what I saw, the character that was coming out of the droids. You've all done incredible things in a relatively short amount of time.
It took us less than a year to go from concept to 3 droids that we brought to the park for the first time. We actually brought spatial AI. We put cameras into these robots so they can actually see as a means to understand their environment, including our guests. And obviously, guests in our parks, we want to have very meaningful interactions. One important item with the BDX Droids is to bring more autonomy to these characters in general. First step for more autonomous solutions is to give them eyes and ears, understanding the environment and including obviously our guests.
So we have these 2 cameras on the robot that are giving video feed to the robot and is using that to understand its surroundings. Here we see what the robot is seeing. So we have a camera feed that shows the image that the robot is capturing right now. And then here is the understanding part. The robot is able to extract from the image a representation of me moving my arms and moving my legs and anything I do. The robot is understanding my movement. If a guest comes in and leans towards the robots can see that. And if he comes back up, You can also see that. You can also see if I'm raising my hand, for example, to wave.
Oh, that's incredibly useful. So we could basically, learn from what you see what the robot is actually supposed to do. Bring more autonomy to these characters. That's really exciting, I think. Thanks, BDX.
We're here talking a little bit about our BDX droids, and we want to turn our lands into stages where the droids can perform continuously for all of our guests and meet as many people as possible.
These droids are so physical. You need to see how they actually work in the physical space, but also work with each other.
What we have here is our droid recording studio, the place that allows us to test and iterate with our creative developers and our shows that can be played back live in front of our guests. We can bridge this gap from core robotics to live entertainment. Ryan, the creative director here, has his script, and we're going to run through this. He's going to give us feedback so he can make the show how he wants.
Okay, action. Right now, we are basically recording a sequence for one of the prototype shows that we've been doing. Okay, start scanning. This is kind of like building blocks. It becomes the autonomous show. And cut. I mean, having one to the left and one to the right is great. Red's just the anchor, doing the bots is great.
Yeah, okay.
Perfect. We don't need this anymore. Let's run it back to what it looks like.
What's really cool about these moments with the droids in the studio is that we can work out sight lines, work out timing. We can figure out exactly what kind of show we want to deliver to our guests. Awesome.
That looks good. Yeah.
Okay, perfect.
One of the projects that I'm very excited about we initiated together is our own J.A.R.V.I.S. J.A.R.V.I.S being, of course, Tony Stark's AI co-pilot.
J.A.R.V.I.S is primarily an internal tool, and really this is the AI ecosystem for Imagineering. We're giving all of our Imagineers the ability to tap into the collective intelligence of all of Imagineering.
We have 70 years of data that we have used to create the greatest attractions in the world. J.A.R.V.I.S was our first opportunity to take and digitize all of that data and be able to give it to an Imagineer at their fingertips so that they could move more quickly. And we've got so many talented Imagineers with all kinds of different backgrounds, and the ability now for them to take advantage of a tool like J.A.R.V.I.S is only going to continue to improve their superpowers and bring those experiences to life.
Faster.
This is the lineage of prototypes that got us to Spider-Man. Over here is the log, the really simple robot, a microcontroller up here, 1 degree of freedom. This pneumatic cylinder controls it. We were able to prove with this, we can take something that's roughly the size of a person and control its rate of spin in the air and how it lands. From this, we went to a stickman, a system that was more precision focused. We also made sure that we can throw this over and over and over again. From 2 degrees of freedom, we came up with a robot that's human size. When you see this move through the air and spin and then drop into a net, I think we can actually do a Spider-Man character. But it also weighs about 150 pounds. Let's go with something smaller, and that's where the idea of Mini-Man came in. Mini-Man is precision machinery, all electric, sensors on board, computer on board. We can animate him to move like Spider-Man would. Let's see if what we are learning with a half-scale model actually translates to a full-size character. This robot, we thought we'd go with something that had the precision of Mini-Man, but now in full scale. And this is the culmination of our series of prototypes. We call it the Mark II. This figure is human size, about 5'9", 95 to 100 pounds, made from printed 3D plastic, aluminum pieces where we need extra strength. We were able to emulate the different types of movements Spider-Man did in the movies. So that's Spider-Man in a nutshell, or in a web.
We started with Lucky the Dinosaur, and we've gone through the Muppet Mobile Lab, even to some of our most advanced robots like Stuntronics in Avengers Campus.
Spider-Man.
It's been an incredible evolution, and now we're bringing even more characters to life.
It's great you brought up Lucky the Dinosaur. It was the first all-electric actuated animatronic. The reason we did that is we wanted to free the audio-animatronic robot from the floor and be able to walk and roam through the parks. And to do that, we tried hydraulics. It was way too noisy. We went electric. At the time, it was challenging because actuators really weren't meant to do what they did, but we figured it out. Lucky really was the start of this idea that guests can interact with these incredible characters.
We
We are looking here at the humanoid character that we recently built. Can you say a few words what we've been able to achieve with this character?
With this character, we really try to push the limits of what we can do with this kind of robot. So in this case, you'll see that she can do a pirouette. A big challenge there is that the foot basically needs to slide while doing the pirouette.
If you wanted to get such performances at the limits of hardware to such characters, what's important for achieving that goal?
These robots, they learn how to do all their moves with reinforcement learning, and that happens in simulation. So basically what you need is a good simulator to be able to achieve these behaviors.
So we recently joined forces with NVIDIA and Google DeepMind to build a simulation framework called Newton. This has enabled us to create a simulator called Camino. And so what is that simulator and what can it do for us in the future?
The goal there is really to extend the simulator to all kinds of systems, basically being able to model any kind of mechanism with closed kinematic loops. This robot, as you see, has all his motors directly at the joint, but for animatronics, often there's no space at the joint, so they'll have to remotely actuate the joint through some linkages, and these are quite challenging to simulate accurately. That's why our robot has about 10 years of practice in simulation. Within the reinforcement learning framework, we ask, please stay as close as possible to this reference motion. The end product of reinforcement learning is a neural network that you put on the robot. Basically, this neural network takes in this current state of the robot and it decides what the next action is. It knows if I'm almost falling over, it will take a step to correct its balance.
This is very exciting. That opens up a lot of new opportunities when it comes to next generation characters.
We are in the mock-up space of Walt Disney Imagineering Research and Development, figuring out how we combine real-time front projection with a mechanical head.
And this front projection is actually being done with just a purely static shell. There is no movement inside the face, yet we're still able to get that very rich micro expression through that front projection.
The texturing that we can get by using front projection is really incredible. The detailing on the skin, we can play around with shaders. We can change the material properties. We can do transformations that we've never been able to do before.
Now, what if it was basically a little more battle-scarred, a little more hardened, and he gets cut right across the face?
So much of this innovation is how we make these characters as realistic as they can so that they convey the emotion that they're feeling to the guests so that we can all be in that story together and have it be real.
Absolutely.
This is a crown that we use for projector calibration.
These AR markers are picked up by calibration cameras. They translate those markers in the physical world to the same positions in the digital world, matching them perfectly. The software we're using to calibrate this figure is software that we've developed right here in Walt Disney Imagineering. It's the same software that's used in the Millennium Falcon attraction.
We want to make sure that that registration is absolutely perfect, and that crown helps us get that done.
We're here at R&D diving in, no pun intended, to this world of aquatic robotics, trying to take over the waters.
This is kind of the Nilu-inspired creature. We built a radio-controlled underwater plane, basically. Servo motors drive ailerons to control the up and down, rolling around. For propulsion, we're using a jet pump.
Just like a jet ski, right?
Exactly. The water gets sucked in, then shoots out. That's what gives us thrust to go forward.
That first prototype, we learned some cool data. We applied it to our next prototype.
We use the exact technology, but on a dolphin. The ailerons are now the fins. This jet pump is a slightly bigger one, so we have the grate, shoots out the back.
We're applying some biomimicry here, literally how dolphins move through space. They're constantly making this sine wave.
We're using two servos. If they work together, you get side motion. If they work opposite, you get the up and down.
Some really natural, organic movement in the center. Now this starts to feel alive. Out of our dolphin prototype phase, we tried something different here with this hydrofoil.
If you look at how this thing works, this pink foam piece would be a character of sorts. The GPS, IMUs in that box to control and be able to do autonomous shows. The tech underneath is basically the hydrofoil technology. Once again, a plane.
A literal plane.
Similarly, we have ailerons controlled by servos, an elevator that does the pitch up and down. We have a rudder that's like kind of the steering tail and a thruster to go forward in propulsion.
With our GPS and our IMU, now we're getting that space of autonomy.
The ship balances itself and then can drive and follow trajectories. So it knows, oh, I'm leaning this way, and then we have controllers to move the ailerons, lean left and turn to get back to my trajectories. And then the second level is the positioning of it all. We use a GPS and also ultrasonic sensors to know how high above the water you are.
Now that we've got the tech in a good place, we're creatively trying to see how far we can take it, how far we can push it, and how to tell a really compelling story with whatever character we're developing for it.
We have a really wonderful partnership with Meta to leverage their Ray-Ban smart glasses for both guest-facing applications and also behind-the-scenes design applications as well. What's great about these glasses is they've got cameras in them, microphones, speakers. For our guests, it allows us to put a virtual theme park guy in their ear. The glasses can enhance the ways we tell stories for our guests, unlocking a world of information about the land that they're in. Just by looking around, I can ask questions about some of the architectural details, and I get the answer right in my ear. Maybe I want to learn a little bit more about a merchandise item for my child. All I have to do is look at it, ask, tell me more information about it. And then right in my ear, I get all of the product information.
One of the more fun but intimidating moments of my job is when we do a big greenfield site, which means nothing's on it, we've cleared it, and you have to go there and start picturing what is it going to be like when you build this thing. And to be able to go and actually have a pair of glasses where you could walk around and get a early previs on the site where this thing's going to be is pretty incredible. Extended reality is going to reinforce the shared experience. A big differentiator for us is that you're there together with friends and family and people that you care about. And every time you have to look down at a device or a phone, it breaks that spell.
Absolutely.
If you can use extended reality, I never stop looking at the environment I'm in or at the people I'm with. It's going to be less disruptive.
We're not just using technology for technology's sake. We're using it in service of that story that we're really going for.
If we're doing our jobs properly, all of the technology goes away and our guests get immersed in the story that we're trying to tell.
The ability to dream up something that might seem completely crazy and watch it come to life is really exciting.
So much of this innovation is about how we make characters convey emotion to the guests.
The thing that keeps me motivated, that family to step aboard the Millennium Falcon, that experience that they'll carry with them for the rest of their lives.
Our vision is to have robots being able to interact with our guests. It's this team that's been leading the charge to try and make that reality.
I could feel that passion walking the hallways.
We're as much magicians as we are PhDs and scientists.
And trying to surprise our guests each and every day. If we're not failing, we're not really pushing the boundaries.
Finding that sweet spot so that we're always doing just what's needed but no more is really key to what R&D brings.
Curiosity keeps leading us down new paths. We call it Imagineering.